Hello everyone, I am Radheshyam Kumar Charosia and I am going to explain my project name Real Time Financial Fraud Detections, which was done on Databricks platform. The main objective of the project is to develop an automated AI systems that detect fraudulent credit card transactions in real time. And to make it automatic predictions easy, I make a scoring mechanism where the fraudulent detect with the help of the scoring mechanism. In the scoring mechanism, I created a probability score for every transactions between 0 to 1. It means all the transactions are associated with a probability scores between 0 to 1, and the project was done in Databricks. So here I created, or the workflow of the project is like that. When any raw or CSV data is uploaded, then it go to the bronze layer, where the bronze layer convert the data into delta tables, because the delta tables helps to perform the acid transactions and also for the relevels cleaning of the data, and it is also good for the large data sets. After converting the raw or CSV files into delta table in the bronze layer, then the data go to the silver layer, where the delta tables are cleaned and filtered in the silver layer, and the, and the data flow from silver layer to gold layers, where different features from the clean data are created, and they are trained a machine learning models named gradient boostings. After training the models, the AI system take decision that the transactions is fraud or not with the help of probability scores associated with the transactions. And the probability score also classify the transaction into three categories. The first is block transactions, and the second one is manual review, and third one is approved transactions. If the probability score is greater than 90%, then the transactions are blocked at that times, and if the probability scores are between 15 to 90%, then they are go to the manual review, where the business data analyst teams check manually for the transactions and do the further process. And if the transactions less than 15%, then the AI system automatically approve the transaction. To make the projects, I download the dataset from Kaggle with 1.3 million transactions record, and in the datasets there are different columns, which there are also a noise columns or a not important column, which I remove and include only the key columns here, like trans date, trans times, means transaction date and transactions times. The column store the transaction date and time of the transaction, and the amount store the amount of the transactions, and the category column store where in which category the transactions are done, and the DOB column means date of birth columns, basically the birth date of the merchants, which also helps to calculate the age of the customer. And there is also a merge late and merge long columns. Merge late and merge long means merchant latitude and merchant longitude, which is the locations of the merchants, and late long columns is the location of the users or the customers. In the feature creations, the gold layer, I derived a distance kilometer columns with the help of the columns which are already in the data sets. I find the difference between the users locations and the merchant locations, and based on this I calculate the distance kilometer coulombs. It also helps to predict the business risk insights. It means if a user swipe their credit card 500 km away from home within 10 minutes, it is high risk that the transaction is fraudulent. And also I create a columns name amount relative to category, where the amount divided by average amount partition by user and category are calculated, which helps to predict also business risk insight. It means like a $500 charge is normal for travels. For a long journey, there requires $500, but there is a suspicious if the user is usually spend such a small amount like $20 on grocery. So the amount relative to category features are created, and after that hours of day and also day of week features are created with the help of time stamp columns, which are present in data with the name of trans date trans time columns. After creating the features, then move to the model training of the datasets. In the model training, first I train random forest, where I train the data with random forest models, which result 99% accuracy but low in recalls, 0.79 precision recalls AUC. It failed to capture the minority fraud class effectively. So I applied gradient boost tree to increase the PRAUC, where the GBT classifier with aggressive 100x class weighting to punish missed fraud. It means if the models missed a fraud transactions, then it give much more focus on the fraud transactions, means it punish the missed transactions 100x. It means one fraud transactions is to 100 normal transactions, and the result of the gradient boosting is 0.77 PRAUC, which is less than random forest, but the ROC AUC of the gradient boosting is 0.99, which is a very good or very accurate result to predicting the fraudulent credit cards. It means the data set is highly imbalanced, so I apply the gradient boostings after the random forest to increase the or to overcome the imbalance problem. And also the gradient boost tree aggressively correct the error on difficult fraud cases than RF missed. It means the transactions which was missed by the random forest are captured by the gradient boostings by giving the more class weight to miss the fraud transactions. In the final evaluations metrics of the gradient boostings are that the ROC AUC value is 0.9953. It means the model is nearly perfect at telling the difference between a thief and the legitimate customers. And the PRAUC metric is 0.7750, means that the fraud is very rare. The model find it consistently without guessings. And the precision is 0.9952. It means our model flag a transaction as fraud, it is 99.5% likely to be correct. And the recall is 0.9781, means the system successfully catch 97.8% of all actual fraud attempts. And in F1, the F1 score is 0.9852. This provides the model is not just guessing, it has achieved a perfect balance between catching thieves and protecting good customers. The accuracy of the model is overall 0.9701. It means across all transactions, both fraud and normals, the model makes the correct decisions 97.8% of the time. And the goal is to make the precision high, because no any one transactions be left, no any one fraudulent transactions should be left. If normal transactions should be tail as a fraudulent transactions, but any fraudulent transaction not be tail as a normal transactions. And the success criteria of the gradient boosting tree models are like: the precision recalls AUC is greater than 75%, means the most of the fraud cases dataset are imbalanced, highly imbalanced. It means that in the datasets there are few columns or few row which was fraud, and there are more row which was not fraudulent transactions. So since fraud is rare, 0.75% means the fraud is rare in any datasets, the standard accuracy is misleading. The model must maximize the detections of actual fraud while minimizing false alarms. And the ROC AUC 95% means that the model must effectively discriminate between the fraud and the normal customers. And for the business explainability, the model must output features importance to explain why a transaction was blocked. For examples, user is too far from merchants. It means for business expansibility, the model also tell the reasons why the transaction was blocked. And for the feature in the feature importance of the gradient boostings tree, the amount is show the most feature importance. The amount column show the most feature importance. It means the amount play a vital roles to predict the fraudulent transactions. After that, hours of day, which was also feature engineering parts created from the timestamps columns, and also relative amount, context, customer age, and specify category under IDX, means the category was pre-processing and converted into pre-processing data, and that become the feature importance for the models. And from my data sets, the business dashboard created is like that. The AI automatic block 35 lakh transactions and approved more than 1 crore transactions. It means the AI in short period of times they save times and block, and also save that large amount of money by by doing fraudulent transactions. And in operational volume count, the block transactions and manual review action recommendations, there is a columns action recommendations where the AI tells how many transactions I have blocked, and how many transactions I have to manually review to check the fraudulent transactions. And in model confidence, the AI basically categorize the transactions with the help of probability scores. When the probability score is greater than 0.9 or 90%, then it treated as block transaction. Then it block the transactions. When the probability scores between 50% to 90%, then it go to the manual review part. And when the probability score less than 50%, then the transactions was approved.